Read the question. I'll put the diagram. This is the and this is the rod. Okay, thin rod. Okay, get into the problem. Read the question. So somewhere look at the rail. This is that rail, parabolic rail, and this is that rod. It is moved now. So what is the EMF? The EMF induced across the connector as a magnitude in terms of Y. Is asking EMF induced across the rod. Fixed rail. So as the rod moves, the rod will have displacement like this. So as the rod moves, so look at the B bar into the plane. As the rod moves, so what happened to flux linking the loop? So what is the loop? Loop is formed like this, no? OA, CB. OA, CB will form a loop. What the area of correction of the loop keeps on increases, flux increases. So d phi by dt EMF will be induced, and there'll be induced current will flow. Let R be the resistance of the rod. So in fact, resistance of the rod keep on increasing. We are not bothered about the current. We are bothered only EMF induced. How to bring that one here? What mathematics you have to bring? So now flux is varying, no? So let me assume an elemental strip. I'll assume an elemental strip. First flux linking that elemental strip. D phi. So let the x is equal to, and let it be y, and this will be dy. B bar everywhere into the plane. So what is the area of the strip? So dA is equal to 2x into dy. And what is y? Y is equal to, we have kx square. I think you can manage, no? So here what is v equal to dy by dt, no? The velocity along y-axis with a constant acceleration is telling. Let's write later on. So we have this much here. So what is the flux linking it? D phi equal to b into dA. So b 2x dy. I'll differentiate this, but we have x also. So what shall I do with x? Can I replace with this? X equal to under root of y by k. We'll differentiate this. We'll get expression for EMF induced. And what I should write with the dy by dt? The dy by dt is what? The v. D phi by dt equal to 2b root k. Y dy is there. Root y dy is there. So this we have to differentiate. How to bring this? I think we can't do like this, no? Or if it were in terms of y, we would have differentiated. Already dy is there. Then this y there. D square y by dt square will come. If we differentiate. D square y by dt square is what? Is acceleration. Can we do? Okay, this will be root y d square y by dt square plus dy root of y. y to power of 1 by 2 minus 1 dy by dt. Somewhere,
Sir,
yeah.
sir, if you differentiate like that, then it will become d square phi by dt, no, sir. Because d phi is already there.
I'm differentiating with respect to time over, no? d phi by dt.
Sir,
Let me end up with mathematics. Let's see that. The d square by dt square is the acceleration. Keep it here. Dy into dy by dt is what v. So this will become dy by root y equal to, this should be 2 will also come. Dy by dt is what v.
by dt, sir.
Dy by dt, no? That is v, no?
That one also dy by dt, sir.
This one, huh?
Dy by dt whole square.
Okay, what I did, let me check it. Dy by dt whole square, huh?
Yes, sir.
Okay, let me do it. This dy is one function, root y is one function, no? UV method I applied.
sir, you differentiated d phi, no, sir.
Uh,
Sir, if you differentiate d phi, what we get is d square phi by dt, no, sir, not d phi by dt. If we differentiate phi, we get d phi by dt. If we are
okay, that
differentiating
one.
d
Yeah,
phi, we are getting d.
d5 here, I should. Oh. The flux linking elemental surface area. Okay, fine. Some assumption I think I made wrong.
Sir, first if we integrate with respect to y, then we'll get the expression for phi. Then we should differentiate, no, sir.
Okay, that one. I think I made some. Yeah. I should find out flux, no? I think I go on somewhere in either way. First, we'll calculate the flux linking this area, then flux as a function of x and y, then we can do further. So this will be elemental area dA. dA is equal to 2x into y. Till here, okay, fine. 2x equal to 2x into dy. So we'll take this one. Y is equal to, what is the equation? Kx square. So dy is equal to 2kx dx. Yeah. dA is equal to 2x. This will be 2kx dx. So dA will become 4k x square dx. I'll integrate 0 to x. Then area will be 4k x cubed by 3. Okay, fine. No? So this, now the flux linking will be B into A. 4bk x cubed by 3. dy by dt is what we know. So this x cube will convert into y. Y equal to kx square is there, no? So this should be 4bk by 3 y to the power of y by k to the power of 3 by 2. Now I'll differentiate. I think now okay, check it. 4bk by 3 y to the power of 3 by 2. Check once calculation. Huh? Solving this will get the required answer. Option C. Okay, this is something. So first flux linking that we have to calculate because two d-phi's I brought it.
So the before method is also correct or not, sir?
D square y by dt square will come into picture, no there. The acceleration
You
again we have
got
to
d phi na, sir.
no, there's a flux linking elemental surface. Then what happened? We should integrate that. Just wait. Some. Are you able to hear me, all of you?
Yes, sir.
The screen stopped, no? I'm here. I'll bring the screen right here. Able to see screen?
Yes, sir.
Not responding. Okay, no. So there's a thing. So check the EMF induced. Constant acceleration is asking. So further velocity, what happened? You can write it as in terms of A. You can bring it. Do calculation. Okay, read this question. So it's a very, very simple one is there. The two rails are there. So there's the first rod and there's a second rod. Full screen not there. Okay, you want full screen. B bar into the plane. These are again take help of some very good application problems are there. So this initially a test rod 1. This is given velocity V naught. It's asking what conditions will arise here. This is a rod 1, rod 2. B bar is present everywhere. And now when you give velocity V naught, negative flux increases d phi by negative EMF induced, positive induced current will flow anti-clockwise. The induced current will flow anti-clockwise, and because of that, here in what direction the current will flow? So I'll starting the explanation. I'm starting from here. So the induced current when the rod has come to this position. So what is the direction of induced current? Will be like this, and because of this, the velocity of this rod starts decreasing, and the induced current I is flowing on this. So because of this current I flowing B bar into plane, so it will experience a force. So how much of force? BIL. Here BIL will be like this. So then this will acquire a velocity V2. So initially V1 will be less than V2, but V1 will be greater than V2. Tell me what will happen. How long this motion of rod like this will take place? How long the motion of rod like this will occur? Because of BL force, continuously velocity of the rod 1 will keep on decrease. The velocity of the rod 2 what happen will keep on increase here. At one instant what happen, both will have common velocity. And once both have common velocity, then what conditions will arise? Both will have common velocity, then the net flux linking the loop remains constant. Though there will be displacement of rod, net flux linking the loop remains constant, and because of that, what happen? No induced current will flow. What should happen to the distance between the loops must increase. Distance between the rods will increase. So you calculate initial distance, say some x naught. This should be x, and this x should be greater. They may ask you any very good conceptual questions. Finally, both will have common velocity. So let mass of the rods be m. Can I conserve momentum? Can I conserve momentum? Yes.
Yes.
What is the net force on the system along x-axis? Zero, no? So initial momentum mv naught should be equal to mv plus mv. So v equal to v naught by 2. Initial kinetic energy of system m v naught square by 2. Final kinetic energy of system of mv square of mv square. So this should be mv square or mv naught square by 4. Now I am asking you kf less than kf. Where do this energy gone? What type of motion the rod one? Retarding motion. So where do that decrease in kinetic energy of system has gone? Momentum of system will not change. Momentum of system will remain same as it is. But kinetic energy of system here decreases. Because net force on system along x-axis is 0. So therefore I'm conserving momentum. Where do that energy gone? So something we should justify, no? Kf less than K. Loss in kinetic energy. So what are the possibilities? There should be some resistance. The rods will have some resistance, and that particular heat will be generated. There's only source, no? Or else, if you go for any other friction is there between the rails and the rod, they'll be utilized to overcome that friction. Anything. So now delta K should be equal to heat generated. There's a possible source. So let me put some resistance for the rod. Very good questions can be asked. I'll connect spring between the rods and I'll project it. You go for further thinking on this one. Now similarly, this is a rail, circular rail, and this is a rod. This is a rail, and the initial position of the rod was here, no? Initially, the rod was exactly at the diameter. Read the question. Meanwhile, I'll draw the diagram. So this was the initial position of the rod. Finally, somewhere at x equal to r by 2. R by 2 I should take like this. B bar everywhere into the plane. So let this be x, let this be y. And this is the radius r. So a wire ring of radius, not for a rod. The ring is having a radius. The ring is a wire ring of radius are fixed in horizontal plane. The wire of the ring has resistance of lambda ohm per meter. So we'll do one thing. We'll break up this everything into two parts. This is A, B, C, and this is D. Arc ADB will have one resistance. Arc ACB will have resistance. Will I agree this? And there's a moving rod. It is given. Find the current through the rod as it traveled a distance x2. constant acceleration. It is moved with a constant acceleration, so therefore it will have velocity. So what is this entire circuit? You should directly come for this. The resistance of RADB. Moving rod will behave like a cell magnetic field into the plane B bar. So this end will be positive. So what is this resistance? ACD. Now calculate this. What is y? Y equal to x by 2, no? Y equal to x by 2. So we'll get the theta triangle x by 2. These are r by 2. Sorry, this is r by 2. Y is equal to r by 2. Is asking a condition like this. Find the current through the rod at an instant it has traveled to a distance x equal to r by 2. This only. I think that x, this x will get confused. So we'll do one thing. I'll make it smaller. Cos theta x by r by 2 by r. Theta will be 60 degrees. Now you know length of the rod. In terms of r, you can bring it. So what is the EMF induced? E is equal to BV into AB. Calculate the length of the rod at this instant. Then calculate EMF induced. And you can calculate the current in the circuit here. Can you work out this? It's very simple. Different types of rails. The rail parabolic, now here circular rail, triangular rail, already we have seen. So different conditions will come. So you should manage with this one. I'll upload in the end. I don't have answer. I have to cross verify it. So and what is V further? A into T, acceleration as a function of time, velocity of the rod. So do calculation. I just gave the idea, share the idea. So we'll take the next one. Once again, I'm coming to rotational EMF problems. I read the question. So whenever that rotating rod, so what you should do? You should replace with a cell, no? So there's a one basic methodology what we adopted earlier, previous classes. At t equals 0, the EMF of the cell is switched on. Then it's asking find the angular speed of the rod at any time t. So I'll do one thing. I'll length L, resistance R. Okay, take this one. Now get into the problem. Where is resistance R? For the rod, you can show it. Here the R will be resistance. Initially, when you switch on, the rod is not disturbed. It is there in that position, and the entire thing lies on horizontal plane. How the mg will act into the plane of paper. Current I will flow. Okay, clear this. So when a current I flows in the rod from A to O, so will there be any BL force will act as BL force. That BL force will start rotating it, and as this starts rotating, then what conditions will arise? Then the rotating rod will behave like a cell. Then EMF will be induced. Then induced current also will come. Then the resultant current will decide in what direction it will move. So initially, so the moment you switch on, so what will happen is a current I1, I'll call it. This current I1 is due to the cell. It will flow in this direction. Don't show in the rings. It's of no use. No, B bar current I. So in what direction this will expense a torque? No, B bar the current. So if you take a small element of length dx, a torque will act in this direction. This torque acting about O will make the rod to spin, will make the rod to rotate about O. As it starts rotating, the rotating rod will behave like a cell. I'll proceed to the next part of the problem. Now in the same, this is called like a motor. A motor, oh, coming ring. Now tell me like what are things I should replace this with a like a cell, no? This one. Let's go for the cell. Let me draw a diagram. A cell will come. What should be the direction of EMF induced? As the rod rotates, B bar velocity. So this should be the polarity. The cell, what it will do, it will push the current in opposite sense. So I1 is in this direction. The cell will push current in this direction. Oh, it all got messed up. Fine, all of you. So why that I1, I2? So what is I1? I1 should be strictly what I should write. I1 equal to E by R. That resistance also I have to show it. I'll show that resistance are here. Then what is I2? I2 should be E by R. What is E? B omega L square by 2R. And what about the angular velocity? Angular velocity of the rod will be in this direction. I don't have space. I'll show it here. Tell me initially which will be greater. E will be greater than small e. So which current will be greater? I1 will be greater than I2. Tell me what happened to the motion of the rod altogether. Due to I1, the torque will be clockwise. Due to I2, the torque will be anti-clockwise. The resultant current in what direction will be towards left. Again, I'll go for one more diagram. I'm showing, let me show only this one. So the resultant, the net current in the circuit will be in what direction? Because I1 greater than I2, so the net current will be in the direction of I. The resultant current, let it be I, and it will be in this direction. Okay, now check it. The torque, it will be B bar and the current. Of the torque will be, the resultant current will flow in this direction. Will there be, what type of motion the rod is going to describe? Come in order. I1, due to I1, the torque will be downward. The torque will be clockwise. Due to I2, the torque will be anti-clockwise. And since I1 greater than I2, so what will happen? The rod, the angular velocity of the rod will keep on increase. The net torque will be downward only, or say clockwise here. Where is the Lenz's law? I1 is the cause, I2 is a opposition. Able to manage the torque due to current I1 is what the cause will make the rod to rotate. And according to Lenz's law, the I2 is what? I2 is a induced current due to induced EMF. It should oppose the cause. So therefore, torque due to I2 will oppose the cause. But since I1 greater I2, the resultant torque will be like this only. Will be clockwise. Okay, let's come for the mathematics now. So what is asking? Angular velocity of the rod at an instant of time t. How to calculate that torque? Go back to some basic formulas I told. So what's be the torque due to this overall current? B square L to power of 4 omega by 2r. Am I right? If you can remember such things, very easy for you. Or else what you should do, assume a small element, the force acting on the small element df, then d tau equal to df into x, then f equal to bi dx, then integrate. Finally, you end up the same thing. Some of you are still asking, sir, how you're writing. I'll just show d tau equal to df into x. So this is bi dx. So this should be bi x square by 2, or the limit will be x dx 0 to L. Bi L square by 2. What is I? I is equal to total net EMF induced. So net EMF induced by the resistance R. So what is the net EMF induced? It should be equal to E minus E by R. You see net EMF induced. Net EMF induced E minus E by R. So further this I is equal to E by R, and what is B omega L square by 2R. So can you write directly this much? The answer is no. Problem to problem, things will change a little bit. This is torque due to induced current only. If you substitute, you'll get torque due to induced current. There'll be torque due to what? Applied EMF. Torque due to applied EMF. So therefore, you have to be very careful about what I said, like will help you. Slightly, it should be modified. I'll take it out this. Now come for this one. So what is the net torque should be equal to? Net torque. So there's a formula, BI squared. So here you are going to substitute here. B L square by 2. In place of I, E by R, B omega L square by 2R. Now write I equal to alpha d omega by dt will be the required answer. ML square by 3 d omega by dt. Solve for omega. So what should happen to omega? Omega should increase with the time. Again, you get a equation of this thing, exponentially increasing. After long time, the EMF induced in the rod will become equal and opposite to applied EMF. The current will be 0. Or this will be terminal velocity, you can call it. So what is the terminal velocity? Directly you can write it. B omega t L squared by 2. Please do learn all this. They may ask you find the terminal velocity of the rod. So directly, after a long time, the induced EMF across the rod should be equal to applied EMF. Okay, see this now. So this mathematics, you have to be very careful. The induced current, there is the expression. Okay, fine now. So for in a rotating structure, then a cell will also come into picture. So go back to same motional EMF ideas is what we have applied it here. Let's come for this. Two conducting rings PQ of radius R rotates uniform in opposite direction with center of mass velocity. They're having rolling motion on a conducting surface. The potential difference between highest points of the two rings. Okay, let's directly come for this. If it is having only rotational motion, what is EMF induced? There's a uniform magnetic field is there. Only rotational motion. What is the EMF induced between these 2 points. If a ring rotates in a uniform magnetic field, will there be any EMF induced in it? I'll come to the problem question later on. First, let's analyze here. Nothing is there. B bar into the plane. Let L be the length of the ring. This is a ring. I'll just rotate the ring about an axis passing through its center perpendicular to plane with an angular velocity omega in a uniform magnetic field, and now B bar perpendicular to plane of the ring and parallel to axis of that. Will there be any EMF induced in that? Will be zero, no? No EMF will be induced. So what is the rotational effect on the ring? What is the rotational effect on the ring? Though due to rotational effect, there won't be any EMF induced. The similar idea. Only due to translative motion it will come. Please do understand this is the idea of the problem. The ring is rotating about an axis passing through its center perpendicular to plane. B bar is perpendicular to plane of the ring. Then no EMF induced in the ring. Come for this problem. They're having rolling motion. So due to rotational effect, there should not be any EMF, only due to translative motion. And only due to translative motion, what we do? We replace the ring. If only due to translative motion, there's everything. So how do it will behave like a cell, no? So what should be the EMF induced? V 2R into this one. So this will be one cell. B bar out of the plane velocity. So this should be this is the ring Q. There's a point Q. Here B bar out of the plane. So this should be the velocity. Now what should be the EMF? What is the length? 2R, no? So this should be BV 2R or 2, and there should be BV 2R, and there should be B 2V. This is 4R. So 2V, B 2V, 2R. Diameter will become 4R. I am replacing this ring with a 2 rods, and the EMF in the 2 rods is what I'm showing like this. So this should be again. It's asking potential difference from X to Y. So let me proceed like this. Vx, is it polarity okay? How to decide polarity? B bar velocity. B bar out of the plane. I think first the left rod I'm bringing polarity. B bar out of the plane velocity. So this end should be positive. Yeah. For this ring, B bar out of the plane velocity. So this end should be positive. So I'll write it Vx minus B 2V 2R minus BV 4R minus Vy equal to 0. No potential difference is set up. So due to rotational effect, no EMF. Due to questions of this kind, very important for exams. Due to rotational effect, no EMF. That one means if a ring, if it is having uniform pure rolling. Let me just describe the basic things. So there's a ring which is having a pure rolling, and another ring let me introduce forward slipping, backward slipping, all. V equal to R omega. V1 greater than R omega. V2 less than R omega 2. Forward slipping, backward slipping, pure rolling. And B bar is everywhere into the plane. What about EMF induced in all three rings? About what point? About point XY. Eight BVR minus negative of negative. Okay, sir. Yeah. Yeah, calculation mistake. Thank you. This one. Check it now. What about VXY in all the cases? Ring 1, ring 2, ring 3. Anybody? VXY in all the cases. Will it be same or different? Due to rotation motion, no EMF induced, no. So therefore, V1, E1, E3 should be equal to velocities are different. Let me put like this. I'll generalize it now. This will be BV into 2R. R is the resistance of the ring. Is it okay forward or backward? Irrespective of that, due to rotation motion, there won't be EMF induced. Only due to translative motion. Please just be careful in exams. They'll try to test with all application part. Why two cells? Because this ring open, you can break up semicircle. No, this is one semicircle. This is one semicircle. Due to each semicircle cell, and carry on the problem. This is something related to SHM. So we have a capacitor here. This is a spring. Initially at this particular position. So this is the initially equilibrium position. Spring is at natural length for this. Some SHM also can be asked. So let this be a rod. Now this rod is pushed by distance x naught. Let me take this as x naught here. So there's a rod AB as given, no? And I'll take it PQ. Because acceleration will be using symbol. So let me make it PQ. B bar into the plane. So what happened? The spring got compressed, no? In fact, the spring got compressed and I release it. So now there's a mean portion. So there's a natural length of the spring. I'll call L naught. What is L naught? L naught is natural length of the spring. This is very important. L naught is natural length of spring. Initially what happened? The spring is at natural length. That's what x equal to 0 is telling. I compressed it by x naught, I release it. Then we have to discuss the problem. I'll make it a little bit more. It's asking us to calculate the time period of oscillation. Little bit some good observation here to make it. Don't do for off cycle. In another off cycle, we don't know how the system will behave. When I release it, tell me what will happen. Spring force will act here, no? This is released from rest. Kx naught will act, and as it starts accelerating, it starts accelerating. Then the moving rod will behave like a cell. Then EMF will be induced. Then the charge will get deposited in the capacitor. Then the rod will accelerate. Then we have to check it. What is the time period of oscillation? Okay, let's. In exams, I don't think so. You can draw so many diagrams. Huh? You have to be. So let this be at a distance x. It has approached near to the equilibrium. Let this be x, that one. This was the initial portion I released it. So now it got accelerated. So B bar into the plane. Check it. Which end will be higher potential? Which end of the rod will be higher potential? Velocity of the rod will be in this direction. Then in what direction the induced current will flow? B bar velocity. So this end will be at higher potential. This will be lower potential. So I can replace with a cell here. Let's have this one. So this will be Q minus Q. So the induced current will flow in this direction. So how BIL force will act on the rod? B bar current. So the BIL force will be acting in this direction. This is some extreme, right extreme. This is a mean position. This will be a mean position. What we have is a right extreme. And what I'm giving is intermediate position. Okay, let's write equation for this. We know there is no resistance here. Look at the entire problem. There's no resistance. There's no resistance in the circuit. So what is the basic equations we can write now? Shall I scroll down? This is t equal to 0. This is at any time t. Now what are the equations of motion? Kx, the acceleration will be towards right. So ma equal to kx minus bil, no? And we know if a capacitor is there, what is q? Q equal to ce, or this is equal to cblv, or this should be equal to I is equal to cbla. So in place of I, I'll write cbla into L. So bringing onto that side. So this will be m c b square L square into A equal to kx, or what is A is equal to k by m c b square L square. And this acceleration is opposite to displacement. So I'll get the time taken, time period. Is it our answer? I think let it pass through the mean portion. At mean portion is the maximum velocity, and the spring what will happen? The elongation of the spring, the differential spring will be 0. Once it crosses mean position, what type of motion is going to discover? The spring force will act towards right, no? Then now the BIL force will be acting, still be acting towards right only. Then it will undergo retardation, comes to left extreme. This is for what is this acceleration from right extreme to mean position. Time taken to move from right extreme to mean is what I can predict here now. So this will be time taken should be equal to 1/4 of the time period. 1/4. This will be 2 pi. Will I agree this? This is what? Time taken to move from right extreme to mean. Right extreme, I'll write symbol m. Once it arrives at mean, it will have maximum velocity, no? Then still what will happen? The induced current will flow in same direction. But spring will get elongated, no? What is the state of spring? Compressed. You see, now the problem will change slightly. You have to be very careful here. Let's come for this. I'll keep total diagram. I'll make it visible. Check it now. See it. Now let it arrive at the mean position will be here. This should not be there. Yeah. And the spring is compressed. A spring will be elongated now. The spring force inward action will act in that direction, but the induced current should be in same direction. BL will be in same direction, and now it will undergo retardation. Please, I think I can show only this much. You have to really understand these two diagrams. There's a mean position, there's a mean, and somewhere here will be left extreme. Now write equation for motion here. Ma is equal to kx plus bil, no? And what is I? I is again same thing after substituting. This will be CBLA. This is it. So this will become M minus CB square L square A equal to Kx. So what is A equal to in this case? Kx by, look at now. So what about this time period? Time period from mean to left extreme. This is the left extreme. How much it should be? 1/4 of what we calculate here. This will be called T dash. And what is T dash? T dash should be 2 pi m minus c b square L square by k. Are the time period same? No. For one of from right extreme to mean, it will have one time period. From mean to left extreme, it will have another time period. 1/4 of time period is what? This one. So now TML you calculate. So this should be equal to how much now? 1/4 2 pi. Try to see in the numerator. You have plus sign, minus sign. So in EMI chapter, you try to be careful about SHM. That's what one question I just brought it here. What is the total time period of the system? 2 times of this, 2 times of this. Agree, no? So time period T naught. So what is T naught? T naught should be equal to 2 times of TML, 2 times of RM plus 2 times of ML. That one. I'm very sure once students reach here, no, what they do? How okay, the same thing will get repeated for in left off, and they'll put answers same, but options are different here. So whenever in that EMI chapter comes, the SHM you have to be very careful. Conditions of SHM comes, you have to be careful. So when you substitute all this one, you'll get the required answer, the time period. Time period of oscillations of the rod. Last one. Okay, read the question. So we have some loop here at t equals 0. So I'll rotate with a constant angular velocity. Thermal energy dissipated in the wireframe when it moves from region 1 to region 2. Total thermal energy dissipated in one cycle. It's asking all the conditions. So it's a very simple, already you know rod concept. So you do one thing, take this as rod. OA1 and this is OA2. Like two rods are rotating and they're connected by arc A1, A2, and angle subtended by that arc is pi by 4 at the center. I'll rotate it. So where all heat will be generated, there's no magnetic field here. And there's a field here. So I'll without any much calculations, you can end up this problem. So don't get into mathematics. Huh? Just treat like a two rods. It'll be much easier. So when the rod is here, when the rod is now, will there be any heat generated? No. Will there be any flow of current? There is no field here. The field here is out of the plane. The field here is into the plane and no field here. I'm making things clear. There's a region 1, there's a region 2. When the rod OA1 entering the region 1, will there be any flow of current? Yes, it should be no. So replace this with a cell, no? It's very easy for you. B bar out of the plane, B bar out of the plane, B bar out of the plane. So this end will be positive. The end O will be positive. So replace with a cell. So how much of EMF induced? Let it be E. So what is EMF induced? B omega L square by 2. So resistance R, and the resistance R is free to rotate. It's also having a total resistance. Let it be R. I'll show it somewhere here. What is the expression for current? Call this current as, say, I1. Now again the same loop. Same loop when it comes here. So when it is entering here. I have to draw another diagram. When the loop is completely inside, I'm just decreasing the size because let me show it here. When loop is completely in the region 1, will there be any EMF induced? Yes, EMF will be induced in individual rod. So what is the direction of that? It should be problem solving very easy once you understand this. Rest all very easy. Huh? And first we'll write what is E. E equal to B omega L square by 2. No EMF induced, no? Again, no. When OA1 in the region 2 and OA2 in the region 3. So what is EMF induced? Here 0. Net EMF will be 0. EMF in the loop will be 0. Any reason for that? Plus C minus C. So when a current I1 will flow, when the loop is entering into the magnetic field or when it's moving from region 1 to region 2. So there's one thing. Similarly, let me show here only one. I'll finish off this one. Again, when it is coming out from region 2, B bar into the plane. Okay, tell me how the direction of induced current should be. Here, no EMF induced in the rod OA2. Sorry, this A1, this will be A2. B bar into the plane and the velocity. So this end will be positive. So this end will be positive and this will be E. And the current now will flow like this. Call this is I3 in this position. And when the rod is completely in the region 2, again no EMF induced. So this is A1, this is A2. All of you able to get the polarity? The EMF, so this is the case here. So tell me when there will be EMF induced when it is entering from one region to other region only, when no field to field, or from region 1 to region 2 also. I'll take one more diagram. This is the loop when one rod is one region, other rod is other region. How the EMF in this should be like this in this direction, because B bar here is into the plane and the rod is having angular velocity omega like this. What about here? The B bar should be in this direction. What about the direction of induced current? Will flow in this way. So let me call this is I2. And the resistance R, I'll show it somewhere here. No. So net EMF induced will be 0. Okay, you have everything this, and no need to calculate, no need to integrate. Just looking at the diagram, you are supposed to write the equations now. When there'll be current, when there'll be EMF induced, when the loop is entering from one region to other region, or when from no field to field, or from field from field it is coming out of the field, entering the field, or coming out of field when one region to other region. What is I1? B omega L square by 2R. What about I2? 2E, no? 2 times both the EMFs will added up here. So therefore, what is the equation? I1 is equal to, I'll write it here. I1 should be equal to E by R. B omega L square by 2R. What about I2? I2 should be 2E by R. Don't go for mathematics. Let me assume a straight flux linking that. This like just like a rod, no? OA1, OA2 are rods. Take help of that and wind up the problem. Now he's asking the thermal energy dissipated in the wireframe when it moves from region 1 to region 2. How much of time? So what is the angle? So what is this angle? Pi by 4, no? So what time it will take to move from region 1 to region 2? It is rotated with constant angular velocity. And a constant current I2 will flow. What is the angular displacement it will have? Pi by 4 radian. So can we calculate the time taken? Question number 153, I'm discussing. 153. So what is the time taken? This should be T should be equal to pi by 4 omega. Then what about the heat generated? H should be equal to I2 square R T. So I2 square will be 2B. So this 2 also get cancels. So B omega L square by R whole square into RT. What is the angular displacement it will have? Pi by 4 radian when the loop moves from one region to other region. Total thermal energy dissipated in one cycle. So where all heat will be generated? Here, here, and this one. So total heat generated, what we should do? I should add up, no? This is one when it moves from one region to other region. When it is moving here, so I'll calculate. I'll do one thing. I'll call this H2. Now heat generated here, let it be H1. This be H3. How to calculate H1, H3? H1, H3 should be equal to I1 square R into say. So let this be time T2. T1 are it. So what is the T1 again? You can write same pi by 4 omega. This is also equal to T3. time taken by the loop to enter fully into the magnetic field region 1. Same thing, pi by 4 omega that one. So we got this much. Now you add up this, the total ETH H1 plus H2 plus H3. Do calculation. So we should avoid mathematics. That's what I'm telling this one. So take help of the rod concept here. Things will be easier. Can be asked questions of these kind of. You have to be careful. Last one more. Or try this in, well, I'll send it in WhatsApp now. You can try this one. Huh? So shall I